Today, we're going to continue with a similar thread that we started in the last session, where we still need to do some work around the champion model. What does the champion model for our final implementation look like, right? Reminder that everything we've done with these individual algorithms has been exploration, right? Last week, we moved it a little further with the time series analysis because we did get into actual modeling and hyperparameter searches and things like that. Today, we're going to do the same thing, but with a different model. And remember that the model is not just different in the approach, right? Because one is time series, one is efficient frontier. It's also different because this is a lazy loader model, which has some inherent differences in how we created it, how we explored it, and it's going to have even more differences that we're going to see today in how we kind of explore the different model options in the champion model process. Okay, so lots of really interesting stuff that we're going to have to tackle today. Some of it might be a little bit crazy. Some of it is going to involve some more complex prompting with AI, but we're going to get through it together. Okay, so I want to be doing a little bit of review from what we covered last week, right? So we talked about how we started with the methodology, right? This methodology guides everything that we do. Data science is not a tool. Data science is not Python. Data science is a methodology. It's a process. So for the sake of us, kind of moving along in the process, we are down here. We are in the model design and interpret results section of the entire methodology. That's the goal, or rather, that's the portion of the process that we find ourselves in right now, right? So we've done a lot of work that have resulted in 3 good ideas, right? We talked about a new sentiment analysis. We talked about the efficient frontier theory, which we know is a lazy loader. And then we also talked about time series forecasting, right? So these are the 3 explorations that we've done. And we've done some model building with the time series. But today we're going to get into the model building with the efficient frontier. What does that look like? And what does that look like for a lazy loader approach, right? And as I said before, all the 3 ideas are viable. We know that because we took the time to do the exploration. But at some point, we have to cut down the list and say, this is the direction we're going in. This is how we're proceeding with the model. This is what gives us the best opportunity to get to a deliverable project for our client, right? So, again, as a reminder, we are basically doing the champion model process. Sounds complex. It's not, but it's a very critical part of the data science process. So what is it? We're going to start with a baseline value for accuracy, or whatever other metric you want to use, right? It doesn't always have to be accuracy, but some metric that you want to hold as a baseline. Design and run the data experiments and try to improve on that baseline number. And then we repeat as necessary or as time allows, right? You might hit a threshold that's acceptable to you or your client. So you got to aim for that, or you're going to run out of time. But that's essentially what the champion model process is. This is us being in the lab as data scientists, right? Chemists have their lab, physicists have their lab. This is our lab. Designing experiments, continually measuring ourselves against a baseline metric, a desired number, is the scientific work of a data scientist. The only difference is that we use data as our tools, right? So that's essentially the phase that we find ourselves in the entire data science process. And we want to go ahead and continue with that and just kind of keep on moving forward down that road. All right? So how are we going to do that? We're going to design experiments. That requires a lot of creativity skills. What are the hyperparameters? And then what else can we use for testing? Are there business use cases or other unknown hyperparameters or different ranges of parameters that we could be using, right? Each one of those represents an experiment. We gotta create, and then once we get into running the experiments, that's more of the modeling skills. So we gotta create that code. What code do we need? What are the resources that we need? Usually resources come down to time and processing power, right? How much time do I have left? How many servers do I have at my disposal? Is that enough time? How much is each training cycle going to take? How many training cycles can I run? So on and so forth. We have to be organized. This is where the scientist skills come in, because we have to basically know what experiments did you run and what were the results, right? And then you also have to know how to recreate that in the future. You have to be able to know what are the hyperparameters, what are the settings, right, for your model that work the best. The settings or weights, you might also think about them as. That's critical because that's the win, right? That's where we win. The whole point of what we're doing is to find those settings, parameters, weights, however you want to think about it. And then we're going to interpret these and we're going to say, okay, which one of these models, which one of these settings gives us the best opportunity to move forward. And that's it. That's the champion model process. Pretty simple to understand, but highly, highly critical part of data science. I mean, like I said, this is our lab. This is how we as data scientists work with code and data to come up with the answer, come up with the otherwise unseen insight, right? I mean, this is the work of a data scientist. So, as we decided last time, we're going to pursue two models. We're going to pursue the time series and the efficient frontier. We did some work with time series last week, right? I think we did some, we got some good results from that. I think we're headed in a good direction from that. But we really didn't do a lot with our efficient frontier theory. So I want to keep on pursuing that. We're going to take the time to review the code for that. We're going to take the time to refamiliarize ourselves with the charts, how those things look like, what those things look like. And then we're going to go through our champion model process. We know we want to use efficient frontier, but what is the best version of efficient frontier that gets us to a good model? Right? That's really kind of like the question in front of us, right? And then, as always, as we've done really in all of these Sunday series, we're going to use the AI first approach to everything we do, right? We have an employee at our disposal. That employee's name is ChatGPT, and it's going to take care of all the coding for us. All right? So let me look at the chat, get some of the questions and more intros. Noor says, yes, this is my first time watching the series. I took online course in probability, statistics, and ML to brush up my memory on these topics. Cool. Maybe it'll come in handy today. Manoj says, I'm doing good, sir. Thanks for asking. Good, Manoj. Glad to hear it. Dendelson says, are we also going to be doing the article writing aspect of our project? I would like to learn the proper way to write one. Dendelson, I already have a video on that, but yes, we'll do that towards the end of this series. Maybe in another 2-3 weeks. Something like that. 2-3 weeks, okay? Yassine, our good friend Yassine says, hello, sir. Yassine from Tangier, Morocco. Nice to see you, Yassine. Hope you're doing well out there in Morocco. All right, guys. So let's get started. I'm pretty sure this is my last slide. Yeah, okay. So let's bring up our friend, Visual Studio Code. I have a feeling we're going to be spending a lot of time in Visual Studio Code. So if you remember, one of the things we did a lot of, or the way we started off last week, was we started off by doing some cleanup, right? Because we kind of had a little bit of a messy directory. And that's okay, because we were just kind of doing explorations, feeling different things out and all that. But we did decide to kind of rearrange some things, right? Give ourselves a little bit more organization. So we have a data folder, our explorations folder, modeling, and predictions. Now, I'm not saying that this is the best folder structure, but it's similar to what I've used in the past. But really, again, do it any way you want. The point is to be organized. The point is to be an organized data scientist that can work in an effective way with their own data, right? Because if we're not organized, we don't know what we ran, we don't know the progress, things along those lines, then how do you know when you're done? How do you know what your results were or what your potentially best results were? You don't, right? So it pays to be organized. It pays to keep things, kind of clean, right? So we did some cleanup. So in data is where we're storing all of our data files. If you remember, we were using the historical data folders to help us with our efficient frontier. These are the files that are specifically used by efficient frontier. So it's using the date, the open, high, low, close, volume, dividends, and stock splits. And it's using that because that is enough data for it to go ahead and determine the wins and losses per day and determine the overall volatility. Because that's what Efficient Frontier is doing, right? Efficient Frontier is helping us measure the returns versus the probability, versus the volatility of the ups and downs of your portfolio, right? And then that's another thing we need to remember, that Efficient Frontier relies on the portfolio approach. It tells you what the most efficient portfolio mix is. It doesn't necessarily tell you the individual stock that you should be picking, right? But that's where we're storing our data, okay? So we want to be conscientious of that because we're going to need this later on in code, right? In our exploration folder, we basically have the different files that we had worked on previously. So we are going to, today, we're going to concern ourselves. Actually, let me go ahead and start closing some of these because otherwise it gets a little messy. So I'm gonna only have the tabs open that relate to Efficient Frontier. So if you remember, we have two files in our exploration. We have the collection of the data itself, and then we have the modeling of the Efficient Frontier. So the collection kind of serves as our data pipeline because we're using a public API to get that data. And then we're using the modeling side to actually, run the code. We know that it's kind of like a Monte Carlo simulation based approach. So it does all those cycles, and then it outputs a chart for us to look at, right? So it works really well. But we still, you still want to separate both of those out because those are very distinct processes from both a coding and a methodology perspective. So one of the things I want to do is, one, we need to update our code so that it better reflects our current data structure, or folder structure, right? Because we've made some changes since we last ran this code. So right here, I can see that we need to change it in our where we're saving it, right? Because the file name is going to be different. We don't want it to be local. We want it to store in the data folder. So what we actually want to do is we want to go this, and then this. That's going to give us a location. It's going to give us the right command to put it into the data folder. So that's the first thing we want to do. And we can verify that by looking at the latest download. So here's the Apple historical data. We're going back 2 years. So the last entry is going to be 11/8/2024, which is, 2 weeks ago, right? That's Friday 2 weeks ago, which is basically the last time that we looked at this code. So we're going to verify ourselves by making sure that the 11/8 date has been updated after we run this. So let's do it step by step and focus on running just the data first, right? Let's make sure that our data pipeline is still solid and ready to go before we talk about our modeling side, okay? So now I'm going to go over the terminal, and let me know if I need to zoom in the terminal. I think this is the zoom I usually have, but let me know if you guys need a little clearer. So let's see where we're at. Okay, so we need to go to explorations. And now we're going to run that. We're going to run the EFF collection. That should look good. Okay, so far so good. Let me go back to VS Code, and there it is, right? Our Apple historical data now reflects up to 11/22. So now we have those additional data points to bring us forward, right? So in other words, our data pipeline works, right? Because now this is code that we would run on a daily basis when we deploy, right? Because you got to deploy a pipeline too. So we're on the right track here. All right. So let's look at the output real quick also. Remember that we also came up with a variety of different ticker symbols. We went through the process where people were throwing out different ideas. You know, somebody suggested, you know, some of these ticker symbols like Tesla or DHI, right? We were looking at a variety of different things. And that's going to be key today. That's going to be key today because remember again that Efficient Frontier only looks at the stock symbols that you give it. It's not going to come up with stock symbols on its own. You're going to have to go ahead and decide what your portfolio looks like or what your portfolio interests are. And then it goes ahead and tells you, if you were to use all of these stocks, this is what it looks like, right? Okay, so we have our data pipeline in place. Let's review our modeling code. So we're going to close out that because we know that the data is good. So this is our data collection code. Here are the ticker symbols that we're looking at, same ticker symbols that we saw on the output. And then if we go into the modeling side, on the modeling side, we tell it where the data is. We ask it to get all files and with historical data. And then we ask it to say, and then we tell it to basically get all the data, put it all into a data frame, get the returns, and then basically figure out what combination of that portfolio gets us the best return with the lowest volatility, right? Here you can see how it's, as I mentioned earlier, Monte Carlo simulation based. And it goes ahead and tells you, or rather it tests all of the different returns and then the volatility, and then it keeps track of them. And then it tells you the end result, it tells you what is the portfolio with the best Sharpe ratio, which is a measure of returns, versus the volatility, right? The up and down. Because you may have a portfolio that makes a lot of money, but also swings quite a bit on a daily basis. And for any number of reasons, that may be an undesirable trait, right? And then we basically output it, right? We're outputting it to the screen. We have two selections of the maximum Sharpe ratio or the minimum volatility. And then we have a plotting function that goes ahead and shows us what that plot looks like. So we need to make an adjustment to pulling the historical data. We know we need to get it from the data folder again. Oh, I think I just. And we're going to get all the files of historical data CSV. And yeah, that should work. So now we're going to run EFF, not EFF collection. And there we go. So here's the chart. Here's the resulting chart for everyone to see. So again, with Efficient Frontier, it's basically telling you on the x-axis, what is the volatility, right? So again, just so we're clear on that, volatility is a measure of the ups and downs, the range, right? It's like a standard deviation measure, right? How big is that standard deviation? And then on your y-axis is your returns, how much money you're going to make, right? So that's basically what this chart represents. So here we're saying that this star value gives you the highest return. It's the highest value on the y-axis while still maintaining a reasonable value on the volatility side. Because we know that things in statistics and numbers, they're not linear, right? You're going to have variance. Variance is part of life. If there was no variance, there'd be no study of statistics, right? So what point along that curve, along that frontier, gives you the best returns and the best and the lowest volatility? That's what that star represents. So in other words, that's our winning model, our winning combination of all these stocks. So this is what it looks like. It's telling us here that if you want the highest Sharpe ratio, which is basically like the highest return, or a measure of return, these are the weights that you should assign to those stocks. Right? That's basically what it's saying. It's saying you should have 1% of Apple, 13% of APP, 6% of DHI, 3% of Ford, 15% gold, so on and so on. So our biggest holding in this one would be NVIDIA, 16%, right? Or if you want the maximum return, but you want low volatility, right? Here's what you should be having, right? You can see that now you don't want NVIDIA at all. You want 0% NVIDIA, which is wild, right? Now you want 0% NVIDIA, and now your biggest holding is IBM. Right? Yeah, IBM, then you got a couple at 13, you got Ford, you got gold, and you got USO. Right? So you can see how it's a different mix based on what are you going after? Are you going after the return? Or are you going after low volatility? And also, what stocks do you have available? Right? Maybe you don't want to consider NVIDIA at all. Right? Or maybe you want to be heavy on something like NVIDIA. Who knows, right? That's really kind of what this is helping you understand. So yeah, you know what? Let me run that one more time just to bring up that chart again. Sorry, I shouldn't have closed out the chart because I think the chart's helpful. Yeah, so I'm gonna put the chart here next to the weighted results so you guys can see them. Right? And by the way, we got a different result this time, right? We didn't change any code, we just reran it, but we got a different result. So in case you don't, if that's sticking out to you and you don't know why, the reason is because it's Monte Carlo based, right? Monte Carlo based, you're not always going to get the same answer. Now, there is a little bit of an asterisk on that because it also depends on how many times you run the Monte Carlo simulation. The more times you run the simulation, the more you converge on a more accurate answer. So in this case, if we go to our Visual Studio Code, I believe we're running it 20,000 times. Yeah, we're running it 20,000 times for our portfolio. So if we were to increase that number, you would start to see more consistency in the charts from run to run. So what this is telling us is that 20,000 is probably not enough. Right? 20,000, there's still a lot of variance in your results. If we were to do 100,000, we might see more of a convergence based on every run that we do. Okay? All right, let me get back to the chat here. Leo says software development best practices 101. Yeah, it's a little bit of that, Leo. Just trying to be a little bit cleaner in how we handle the directory and all that, right? Because this is definitely a lot more of the software development side of data science, guys, right? I mean, I think that's clear to everybody. We just don't happen to be writing a lot of that code ourselves, right? But you still want to be organized and, still have some pretty good software development practices under you. Lakshmi, hey Lakshmi, how are you? Good to see you. Lakshmi says, morning Dennis and everyone. Morning to you too. Hope you're doing well out there. I know you said it's your dinner time, so hopefully you ate and you're done. And you're ready to spend a couple hours with us. Tej, good morning. He says, hi Dennis. What symbol is USO? I believe it is USD. No, it's USO. So USO is the ETF that represents the US oil industry. But again, guys, I don't want you to get too caught up in that, because the point here is not to teach quantitative finance. The point is to teach how to find champion models, right? So yeah, it represents the oil prices here in the US. So it represents refineries, exploratory companies, things along those lines. But it's just a general oil investment vehicle. Penguin says hello. Hey Penguin, how are you? Good to see you. You're welcome to stay on Instagram, but if you want to see things a little clearer, you're welcome to join us over on YouTube. Okay. Okay. So we know that our pipeline works. We know that our efficient frontier code works because it gives us, it runs the test, it gives us the outputs that we'd like, right? So what's next? Let me know in the chat. First opportunity for participation. Where do you guys want to go next with this? We updated our code, we refreshed ourselves with the fundamentals of what we're pursuing here. What's next? What do you guys think? Let me know. Let me know in the chat. What's next? Where do you guys want to go next? Michael says, Sunday blessings, Dennis and everyone. Hey, Michael, how are you? Our friend from Nigeria. Doing well, Michael. Hope that you're doing well too. So, Michael, the question in front of the chat right now is, what are we going to do? What's next? We have a data pipeline for Efficient Frontier. We have pretty good code for Efficient Frontier. What's next? What are we as data scientists going to do next? What do you think? Penguin says, I was going to go to YouTube, but I won't be able to comment. Why not? On YouTube, you just have to be a follower. That's all. There's nothing to pay or anything like that. If you want to be a member, I do have memberships for sale, so I do appreciate your support via that way. But to comment, you just have to subscribe. That's all. Tej says, just looked it up online. It is United States Oil Fund. Yeah. But, Tej, again, the point here is not to be investment advisors. The point is to just have data to work with, right? Okay, so Yassine is volunteering his answer. Thank you, Yassine. Maybe to find the hyperparameters to experiment with. Yeah, that's exactly right. Yassine got it right from the beginning. We're scientists, right? Scientists run experiments. We have code, but so what? Right? So what? We need to be able to have hyperparameters to test. As I've mentioned before, this is what I call this is what I tell my teams. You got to have levers to pull, right? You got to have different levers to try and experiment with, and all that. You're not done. Your model's not dead until you run out of hyperparameters, right? So you got to be able to come up with experiments to be able to say, okay, well, look, here's my hyperparameters. Here's my range of values that I can try across those hyperparameters. And then every permutation of those represents an individual experiment, right? So here's the thing. We know that this is a lazy loader. And we know that it's a Monte Carlo based approach. So there's really not as I see it, a ton of hyperparameters to work with. At least not traditional hyperparameters to work with. Because you can see here that this is kind of, if we scroll down here to line 29 and we look at this loop here, where it starts with run the Monte Carlo simulation, this is basically the heart of our entire effort, right? Like this is where like the loops are happening. But we're doing it without a library. We also know that we're doing it without a model to save. There is no fit function here, right? So, and remember, there's no fit function because it's a lazy loader, right? Everything is happening within the file at runtime. There is no save model for us to instantiate. So it's basically like a math formula that we're running, right? So what do you think? What are the hyperparameters? And remember, we're still going to take an AI first approach. We're still going to ask ChatGPT what it thinks. But I want to get your thoughts first. What are some of the hyperparameters that we can come up with? While you guys think about that, I also want to talk about another thing. We also agreed that we need a metric to measure against. We said that we need a metric that is what we're going to hold as our baseline. And that essentially determines the champion model. Whatever model comes up with that best baseline, that's the winner, right? That's who we want. That becomes your champion. So we have the code that we have has given us basically two different metrics, right? We have we have the returns, and then we have the volatility, right? What gave us the best return and what gave us the lowest volatility? So that's the first one. That's the second one. So for the purposes of us moving forward, we're going to say that we had a conversation with the client. Because remember, we're a tech team, not a business team, right? So we're not going to decide which one we should use. But we had a conversation with the client, and the client says that they want to go ahead and look at the portfolios with the maximum returns, with the maximum Sharpe ratio. Right? The maximum return is what we want. Because they are okay with risk. They are okay with that volatility of the ups and downs. They're finance professionals, they can handle it. They're willing to accept that. Your average person on the street, they may not want that. They may want the low volatilities. In other situations, you might have investment funds that require a very low volatility approach, right? But that's getting outside of data science. So we're going to go ahead and say that they want the maximum returns, right? So we're essentially going to remove or delete this portion of the code, because we're going to say that the client doesn't really care about this. Okay? So we're going to delete that, and we're going to say we're going after the maximum Sharpe ratio. And actually, you know what? I'm actually not going to delete it. We're going to ask ChatGPT to do that. Because just like we did last time, we're going to keep the exploration code, but we're going to create a brand new file. We're going to start by showing ChatGPT our current code, and then seeing where ChatGPT ends up with it. All right. Okay, so again, the question in front of the chat is, what are the hyperparameters? What can we adjust? What is within our control to adjust? So Yassine says, I guess the stocks chosen, their count, and their nature. Okay. I like that, Yassine. Does anybody else agree with Yassine? And then let me look at Tej's comments before returning to Yassine's. So Tej says return or volatility. Yeah, so Tej, return or volatility in this scenario are not hyperparameters. They are our metrics to measure against. You can either have a high return or a low volatility, right? So for the purposes of making a decision, I'm going to say that we spoke with the client and the client said, we're okay with high volatility. Give us the maximum returns possible. So we're agreeing that the metric that we are using to measure all of our experiments against is the return. So again, I love that you narrowed in on those, but they're not hyperparameters. They are metrics to measure against for the baseline. So our goal here, if we kind of return to our the hypothesis that we're pursuing or the investment thesis, we are saying that we can use data science and a Monte Carlo based efficient frontier theory approach to finding the maximum return for a portfolio, finding a portfolio with the maximum return. That's essentially what we're saying. Okay. All right. So let's return to Yassine's earlier comment. So Yassine says, I guess the stocks chosen, their count, and their nature. So Yassine, I'm going to the stocks chosen, their count, and their nature. Lakshmi says stock weight. Yeah. So Yassine, I guess I'm a little stuck depending on what you mean by their count. If you mean their count by stock weight, or stock weight, as Lakshmi also says, then that's not 100% accurate, because remember that the output that we get from the model is the stock weight, the proportion that it should be of our portfolio, right? So it's not so much, so we really can't control that count, because that's kind of what we're pursuing. We're pursuing the ideal value there, right? Now, if you're referring to the number of stocks in the portfolio, now that could be interesting, right? And that's where I think Osama's answer is going, right? So Osama is saying number of assets. So yeah, that could be a hyperparameter, right? What is the best 3-stock portfolio, 4-stock portfolio, 5-stock portfolio, right? Okay, so Yassine says, no, I mean the number of stocks. Yeah, okay, cool. I agree, right? That is a hyperparameter, right? Let's say that we can tell our client, Manoj says agree with Lakshmi. Okay, Manoj, I'm going to come back to that, but let me stick with Yassine's. So Yassine says the number of stocks. Yeah. So if that's what you and Osama meant, then that's great. Because we could go to our client and say, hey, our model can produce portfolios for your clients or for you based on, here is the best 5-stock portfolio. Here is the best 10-stock portfolio. Here is the best 30-stock portfolio, right? Those would be a valid hyperparameter to test. So I hear you on that. I like that. Okay. Manoj says agree with Lakshmi. So Manoj, as I mentioned earlier, the weight of the stock which is the proportions that we're seeing up here in the terminal, right? Something like this 6.29, 28.17. That's not a hyperparameter. That's the result. The algorithm gives us that result, right? So no, the weight, the stock weight, or the proportion of the portfolio, that's not a hyperparameter. We're pursuing that, right? And that's kind of where it gets tricky, because now you got to sell the client on that. Like, think about that. What if this was the winning portfolio? That means we're saying that our client should stay away from NVIDIA, right? 0.56%, right? That's like nothing. I mean, that's kind of like where the data science sales part of it begins, right? Because you might get pushback on that. What do you mean we shouldn't invest in NVIDIA? The AI is super hot, like blah, 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 right? But that's the way it goes, right? You have to do that. So the weights is kind of like the result of the data science, not a hyperparameter for it. Okay. Osama says number of simulated portfolios. That's a combination. That's a function of the tests, right? The permutations of the hyperparameters. Osama. So yeah, I don't think we can really do that. Tej says the time period and time interval of stock data. Well, there is definitely something to be said for putting more data into a model, right? But I'm not sure that we're quite there yet, because you would only do that after working with a model and figuring out that you're not really getting anywhere. So actually, maybe I should have started that differently, but that is a common mistake that I've seen some data scientists that are earlier in their career make. That they think the solution is always more data. Sometimes it helps, but not always. So don't be tempted to think of data as a hyperparameter, because it's really not proper to say that. You can try more data when you get stuck, or if you want to try to introduce more features, like you want to go back to a feature engineering stage, that could be helpful. But strictly speaking, more data is not a hyperparameter. Okay, so keep that in mind. It can be a little bit dangerous to go down that road. All right. So I think that we're on the right track here, because I think that here's what I'm seeing in the chat. I'm seeing two different approaches or two different suggestions for trying different portfolios. And that's going to be the stocks chosen, right? And the number of stocks, right? So at least 3 of you were on board with those. I think those are valid approaches. Let's go back to the code. So if we go to the very top of our code, remember how I told you that we modified this, and then it uses, the fuzzy search here to get all files with historical data. And then it takes all of those files and puts them in here and creates a data frame and so on, right? Well, who says we need all of those? Maybe we should be trying random combinations of portfolios. Some will contain so many stocks, others will contain more, so on and so forth, right? Some will be 2 stocks, some will be 5 stocks. And this 5-stock portfolio may perform differently than this other 5-stock portfolio, right? Those are valid tests. Because now you're putting yourself in a situation where you're going to find those insights that don't jump out at you on a page, right? That's the whole point of data science, right? If I can find it analytically, then you're not doing data science, right? But if we incorporate those types of tests and we incorporate it into this Monte Carlo based approach, now we're putting ourselves in a position to find those insights. Now you were putting yourself in a position to impress the client and say, whoa, wait a minute, we would have never come up with that combination, right? So like now you're you're doing something good, right? So let's get started on this. Let's get started on coming up with that code that actually is static. We're going to show it to ChatGPT as a basis, but then everything new is going to go in the EFF modeling file, because that way we can kind of separate out our efforts. Okay. Lakshmi says testing with another set of stocks and number of stocks. Yeah, Lakshmi, that's essentially what we're going to do right now. Okay, so to Lakshmi's point, I feel like we have to make some changes here. Don't you guys feel? Well, it's really not a question of feeling, but remember that, data collection, you determine the universe, right? And we have chosen that universe by saying that we are only interested in these stocks, right? We're saying this is our entire universe of stocks to look at. Our data, our model will not know anything else beyond this. So that's the first thing we should do, right? We should expand our pipeline. Our pipeline right now is this. We need to expand it to be a lot bigger. Okay? Because the more we have, the more we're going to be able to put ourselves in that position to say, okay, we found some good stuff here. Okay? Leo says, anyone else having issues with YouTube? Let me see how that's running, Leo. Is YouTube okay on my end? YouTube generally looks okay on my end. So maybe somebody wants to give feedback to Leo. But things are looking good on my end. All right. So let's start with that, right? So let's expand our universe. We're also going to say that our client has said, I only want to invest in big stocks with a lot of volume. So what we can do is we can ask ChatGPT to come up with a list of ticker symbols to help us. And we're going to ask for the top 50 ticker symbols on the US stock market. Okay? All right, so let's start there. So let's show what we're working with. Okay, it's going to give us a verbose answer that we really don't need, which is kind of annoying. All right. So this is what it's going to give us. So not really surprised. Some of these we already have, right? So there's NVIDIA, there's Palantir, right? Here's Meta. I don't think we had Meta. Here's Uber. KO, I believe, is Coca-Cola. Tesla is here. I believe that's Intel, INTC. There's Google. CRM, I believe, is Salesforce. I believe that's a Salesforce ticker symbol. And so on, right? There's even a Bitcoin one in here, or Coinbase, right? I'm pretty sure Coinbase is coin. Netflix is in here. I believe this is Eli Lilly, which is a pharmaceutical company. So makes sense, right? So now this becomes our universe for our data collection, right? Now we've put ourselves in a position where the model is enabled with a much bigger window, which increases our probabilities of coming up with something unique, right? So let's start with this. We're going to pop this into our data collection, and we're going to go from there. So here's our data collection. We're going to replace sticker symbols. Did I not copy that? Here. Okay, there we go. Yeah, so AMD is in here, Walmart, JP Morgan. So this is perfect, right? So now let's go back and rerun our pipeline. Gotta close out this here. So we are in explorations. We want to go one level up, and then we want to go back into data, and then we want to run. Oh wait, nope, we didn't want to go back into data. We wanted to stay in explorations. That was my mistake. Yeah, so we want to go Python EFF collection.py. Okay, so now you can see there's a lot more data being brought down, right? Which is what we want. We want more possibilities for these permutations, right? Because if you think about it, right? I agree with the suggestions you guys made. We're on the right track to try different numbers of stock. So the way we improve our probabilities is by having more stocks to choose from, right? Because then it becomes a probability problem, right? Choose 10, or if we say that we're going to say, give me the best 10 stock portfolio, now you're choosing 10 from 50 instead of 10 from 12 or 10 from 2015, right? There's more permutations, right? I think somebody can correct me if I'm wrong here, but that's an N problem, right? It's 10N50 that we're now doing, or 5N50 if we want to do that. And that would give you the different permutations that you're now going to test, right? Or that are available, I should say, right? So that's great, right? You want to increase those probabilities, that field that you're going to explore, because the more you do that, the better off you're going to be, right? All right. So here's where we're going to apply just a little bit of domain knowledge, right? We talked about the different stock value, or excuse me, the selection of these stocks and the size of the portfolio, right? There are theories in investing that say that all of this investing stuff is nonsense, that a random monkey choosing stocks could do just as well as anybody else. So couldn't we combine both of those ideas that we had? Couldn't we combine and say, not only do I want you to give me portfolios of 3, 4, 5, 10 stocks, but I also want you to pick those stocks randomly, right? What if you just said, you know what, go to it and just do it randomly? Like, why couldn't we do that? We'll say do it randomly. A portfolio has to have a minimum of 3 stocks and a maximum of 12 stocks. And you can pick randomly, but go ahead and start doing that. And then just give me the results as we go along. Couldn't that be possible? I think it could, right? So let's try to write that script. It's going to be complex, just like last week. Last week we wrote some of the most complex prompts to date. This prompt is also going to be complex, but I think we can do it. I think it makes sense to do it. So we're going to start by taking our current code and making some of these changes, right, that we've talked about. One of the first changes that we need to make that I can't believe we didn't do previously is, if you notice, another thing is that this right now is all a Python script. It's not a program. We don't have a main entry point. We don't have a lot of other different things that we need to have going for ourselves here, right? So let's do that at first to make sure that we have a good program to work from, not a script. So we're going to take our code. We're going to go back to ChatGPT, and this is where the prompting begins, guys. All right, so well, let's give some positive feedback here. Okay, so it immediately recognized it as us doing Monte Carlo simulation for polar optimization, right? Which is great, right? Okay, so first change, first. So one of the most recognizable ways of a program versus a script is that you also use a class and you use a main entry point. So we're going to ask it to refactor this code to do those same things, right? Utilizes a class and a dedicated entry point with a main function. Please. Let's see what it gives us. Okay, that's some very slick code from what I can see. So we are in our EFF modeling. Oh man, they made a mistake. So should be the same code, same functionality, but a little bit of a different way of looking at it, right? So here's our main entry point at the very bottom. And then we have our main function. And then we have our portfolio optimization class. That's a brand new class that was created, right? We didn't have that previously, right? We were kind of messy earlier working in a script. I can't believe we hadn't done that previously. So that's my fault. In our class, we can see that we're setting a bunch of different local class variables that we're going to need, right? The number of portfolios is the same 20,000 value that we were using for testing. That's what actually determines the number of Monte Carlo cycles that we're going to run. And then basically everything you see here with the nones are going to be some of the return values that the code is going to produce for us, right? Which is kind of like what we want, right? So here you can see that it's loading the data It's going to calculate the returns, and here's where it actually runs the simulations, and so on and so forth. Down in the main function is where we're setting some general parameters. We're saying that here's where our data is. Here's where the number of portfolio simulations we want to run. Here's the call to the class itself. And then it goes ahead, loads the data, calculates the return, runs the simulation itself, gets the portfolios, right? This is the get optimal portfolios call. And then it fills in these two different variables, right? What is your max return? And then what does your min volatility portfolio look like? And then it basically outputs it, right? So the first thing I want to do is I want to actually run this code just to make sure that it was refactored properly. It looks pretty good to me, but you never know, right? You got to test these things. So we are no longer working in explorations. We are now going to be working in our modeling folder, right? And then we have our EFF modeling, we do. So now we're going to run that. We should see no difference in output, right? That's kind of the goal. Well, actually we should, because we have a lot more portfolio to pick from, right? I mean, look at this. It picked everything. So it picked everything. And there is a slight difference, isn't there? It didn't show us, it's showing us the proportion, but it's showing it to us in decimal instead of percentage format. Previously, we were getting it in percentage format, right? We were getting it like this. But now, for whatever reason, the output is in this format, which is not the worst thing in the world, but I kind of liked it the way it was before, right? It was a little bit more convenient before. But here you can see how it's using basically every single output out there, right? And that's okay. We know that there's going to be 50 stocks that we downloaded data for, but that's part of what we're going to test, right? Part of what we're going to test is we're going to say, hey, this is what your better portfolio looks like, because it only has these 5 stocks or these 6 stocks or whatever the case may be, right? On the plotting side, you can see that the plot generally looks the same. So the code did a good job of refactoring it and still keeping both the plot and the text output that we wanted. So I think we're on the right track, right? What do you guys think? Let me look at the chat. Looks good, Leo. Thanks. Nice to see you being polite when prompting. Hey, never hurts to be nice. Leo says, but why randomly? I'm a bit lost. Okay, guys. So Leo, remember that ultimately, what is data science, right? The data science is the removal of bias from your data decisions, right? That's what we're pursuing. So if we didn't do it randomly, it would be really, really hard to avoid bias, right? Because we'd be saying, oh, we're AI people, so let's include NVIDIA in there. Let's include AMD in there. Or some people might say, oh, well, JP Morgan's my bank. Let's make sure we include that in there. I really like shopping at Walmart. Let me include that in there, right? It would be really hard for us to avoid bias unless we said, well, we got to do it randomly, right? That's kind of like the randomness is how you eliminate the bias. Otherwise, it'd be very hard to say, well, we're telling you that this is the best 5 stock portfolio because that's what the algorithm told us. Because it's not what the algorithm told you, it's what you, the human, chose. Right? So you haven't removed bias. You haven't let the data speak to you. you're allowing yourself to be potentially manipulated by your own thoughts, your own perspective into the model. So you kind of have to do it randomly in order to be able to say, I've done as much as I can to remove bias from my selection. Does that help, Leo? Or does anybody else want to, kind of take a shot at helping Leo understand that? Or maybe some of you can say, hey, I'm equally lost like Leo, right? But you have to do it randomly. Otherwise, you can't say that you remove bias. How else would we pick the stocks? Like, we really couldn't, right? So let me know what you think about that, Leo. All right. So let's go back to ChatGPT. And you know what? I'm deciding that this is kind of irking me a little bit. I want to go ahead and see the percentages. So let's make that change quickly. Let's see how good ChatGPT can interpret that change. Going to give us all of that. And by the way, we could have probably done that ourselves, but ChatGPT is our employee, right? It takes care of all our programming tasks. So we're going to go ahead. Here's the updated version of the results display. Oh. I see. But we always want to do the entire file, not just this. It only showed us the main function, which is not terrible, but we always want to, take a new file. Okay, so here's the entire file with the revised changes. So let's wait for that to, finish up, and then we'll go ahead and pop it back into VS Code and rerun it. All right, we're going to copy the code, go back to Visual Studio, and then we should be ready to rerun this. Close this up. Okay, so to me, that's a little bit of a cleaner looking output. We also got another chart. Okay, so this tells us a little bit more about our actual holdings in the portfolio, right? This is good. This is good. This is the one with minimum volatility, and this is the one with the maximum return, right? And by the way, you can see that these numbers are terrible. This one is offering a return of 0.59%. This one is offering a return of 0.44% with very low volatility. So it tells us that using 50 stocks might be a little bit too much, right? It might be spreading our investments too thin, right? So just as an observation, right? Again, we're not a business team, we're a tech team, but it's good to know these things just to kind of establish that baseline in our mind, right? To say, wow, wait a minute, how is that number so low, right? All right, so I'm good with this, right? So in the chat, let me know if you're in disagreement, but I think that we're going to go ahead and say, give me select a random value for the number of stocks that you want to evaluate, and 2, make a random selection of which one those stocks should be, right? So we're going to ask it to both randomly select 3 to 10 stocks, and then which stocks make up those portfolios, and then run the simulation. Because that's the combination of ideas, right, from Yassine and from Osama, I believe, who talked about like the number and the selection of stocks, right? So that's really, and those are valid hyperparameters. So Leo says, I see, but isn't the best stocks portfolio already some sort of bias? I understand your point though. Is it just that picking randomly makes it feel like we might be neglecting some best performing ones? Best performing by what measure though? Like you don't know that, Leo, right? You don't know that going into it. See, and that's what makes it hard. Because you might say, well, I always see a lot of people at Walmart, so Walmart can't be performing bad. That's got to be a good performing one, right? So like there's no reliable measure for you to say like that we should include this. Excuse me. There's no reliable unbiased measure for you to say we should include this. Right? That's why the randomness works. So Leo adds, I also meant like the only thing those stocks have in common is their good performance, but for a hedge fund, would that be enough? Well, but again, Leo, we're not really teaching quantitative finance here. This is all pretend, right? So, I mean, hedge funds don't really invest in a lot of these stocks, right? I mean, we're just talking about finance companies in general here. So it's more about understanding the framework that we would use, right? The lesson here is not don't invest in Tesla. The lesson is sometimes you have to develop your own hyperparameters, and sometimes those hyperparameters have to be random, right? Because that's really what you have to do. Because remember, guys, we're not using a library, right? This is pure code, and it's not a fit model. Fit models tend to have more built-in parameters. They tend to be bigger models, a little bit more complex, right? So this is much more about learning how you handle a lazy loader. Because keep in mind, we didn't have this conversation last week, right? Why? Because Prophet has 10 different hyperparameters that ChatGPT told us about, right? I mean, that's why we didn't need this conversation. But sometimes you do have to be creative with the hyperparameters that you're working with, right? Yeah, Tej, I love you, buddy, but this is a terrible suggestion, right? Terrible suggestion. Is it possible to filter out stocks that are above a certain PE rate? Why? Why the PE ratio? What is the threshold you would use for that? You can't give me unbiased answers with that, right? Like, we don't care. That's the insight. And again, this isn't a quantitative finance course, right? The insight is that you're doing it randomly to come across things that you never would have previously. And you're doing it in an unbiased way. So, I'm not mad. I'm just disappointed. Yeah, Tej, I mean, you got to get away from thinking about this as a finance exercise. It's a data science exercise, right? We are trying to remove as much bias from the decisions as we can. So talking about individual metrics and then a threshold for those metrics, that's a massive mistake on top of a massive mistake, right? Lakshmi says, partially relating with Leo, we might be neglecting some best performing ones. But what's best performing? So, I mean, guys, if you want, put it in the chat. Give me a measure that you could use for best performing that does not have some portion of personal bias into it. You can't. right? But if you guys want to try, go ahead and use that as a thought exercise. The randomness is what creates the unbiased approach. AJ says, could we use S&P 500 as a baseline and choose a portfolio that beats the S&P 500? Well, the Sharpe ratio is already a measure of that, right? I'm pretty sure the Sharpe ratio already takes what baseline investments could net you versus this investment, right? I'm pretty sure that's the case. Yeah. And also, AJ, I don't know if I'm on board with using any other baseline to compare against, because our goal is to give a solution that reflects the data. And we need to be open to saying, well, you're better off with the S&P 500 or something else, because this is what our data gives us. Our best efforts give us X. If you think you can do better than X in other avenues, other possibilities, then you should pursue that. But from our perspective, from the task that we've been given, with the data that we have, this is the answer we have. This is the best answer we can come up with. And that's okay. It's totally okay to do that, right? All right, so let's start moving forward. Let's keep going with the changes for our code. So the next change I want to make, because we're going step by step here, right? We could be doing this in a single prompt, but I want to go step by step. The next change we can make is we can say, forget about the volatility. We just want to know the Sharpe ratio, the best return. So let's go ahead and do that. All right, let's see what this gives us. So I've asked it to basically keep the plots unchanged, because I have a feeling that's going to be useful for us in the future. But from now on, we should only get one result that shows us the portfolio with the maximum Sharpe ratio, and then that will show us the return. All right. Is that done? That's still working, geez. All right, let's copy that, put that back in our Visual Studio, and then we're ready to run this again. All right, so from now on, we're only getting the maximum return, and that's it. That's all we care about. It's still plotting. It's still plotting the return, volatility, and the Sharpe ratio up here. So now we're here at this green arrow. So we're basically saying we're okay with the highest return. We don't care what the volatility is. Just go for it. Okay? Because again, we're pretending that these are the instructions that was given to us by our client. That's what best fits their business needs. All right. Okay, so now we're gonna get into the randomness of it all. And let me check the chat. Let me check the chat here. Dennis, I was thinking real hard about the shipping company optimization problem we talked about in the last week. Hope you have a couple minutes at the end to answer a few questions about it. Yeah, sure, AJ. Yeah, let's save that towards the end. All right. So now we're gonna get into the stickier parts of the updates, of the prompts, I should say. So we're going to say that the client told us that they want to see portfolios that contain between 3 and 12 investments. That's what they're comfortable with, right? That's a business rule, not anything else. So 3 and 12 stocks. Let's see. All the data I have. All right, so we've done a pretty good job here of describing what a single instance does, right? We wanted to pick a size between 3 and 12 stocks, and then from all the data files, I want GPT to make a random selection of stocks based on the size of the portfolio and run the simulation. But we want the trick here is that we have a simulation on top of a simulation. This is one instance, but we want to run this instance multiple times, right? So we want to make sure we include that. And then please run this entire instance. And we'll make that a settable value, but we'll just start off with 50 times. 50 times. And then we also want to output it, right? We talked about being organized, create a report for yourself. So we also need it to take that output and say, or run a simulation and then output it, right? To some sort of report, right? To a CSV file with the number of stocks, the ticker symbol, the weights for each stock, and the associated return and Sharpe ratio for that portfolio. All right. I think that prompt is going to do a pretty good job of getting us there. I hope. Okay, dynamic portfolio sizes 3 and 12 stocks, randomly select stocks to portfolio and then run the simulation 50 times. After each simulation, results are saved to a CSV file. Okay. Is that done? Nope, still doing. Okay. Let's copy that. Let's take it into our Visual Studio Code. This one's going to require a little bit more of a critical eye. Oh, wow. It actually looks pretty good. All right. So we can see that our main function is significantly different now, and that's okay. You can see that our class is now going to have a new function called prepare random portfolio. Pretty sure that's new, but it's going to use everything else, right? It's going to run the Monte Carlo simulation. It's going to get the optimal portfolio and go ahead and run, right? And in here, you're still running the same portfolio, right? And here, it's going to output it as it's running. So my concern was for it to understand that we want to run multiple instances of these same random selections. And I think it's done a pretty good job of doing that, because this is the key line that I was looking for. Because this line here represents like our meta simulation of the number of portfolios that we want to test for. Right? So I'm kind of encouraged that it did so well in creating these portfolios. Okay, and it's going to output it to portfolio results CSV, which is great, right? And it looks like it's going to do it after every simulation. So that's not so great. I was hoping that it would do it as a single file. But it looks like we're going to get one file after every single run. So that's something to modify in a future instance, but it shouldn't stop us from running this code now. So let's go ahead and do that. And by the way, guys, I'm kind of pushing forward just a little bit ahead here, because I think that this would help you. This should help most of us, or most of you in the chat that are still having questions about the randomness and the P ratios and best performance, right? Let's keep going down this road here. All right, so EFF modeling. Oops. All right, so we're going to basically run the same file. Okay, so we have an error. Population must be a sequence. Population must be a sequence for dictionaries or sets. Use sorted D. Interesting. Selected stocks. Okay, in the random portfolio. Selected stocks, random sample, self.data.keys, portfolio. Okay, so it doesn't like this line. Population must be a sequence. Interesting. So it doesn't like portfolio size or the data keys. I'm guessing it's the data keys that it doesn't like. So let's see if ChatGPT can successfully correct itself. Random sample, like the list, self data keys, into a list. Here's the corrected code. Okay. Okay, so it gave me just that function, so that's okay. We can replace that. What was it again? It was prepare random portfolio. Yeah. Yeah, so you can see here it made that change where it made self-data keys into a list. That was not there in the previous instance, which was my gut feeling on why that would happen. All right. Okay, so there we go. There's our simulations. So we're going to get 50 of these files. So let's go ahead and start checking them while it still runs. So here they are. So here's our first simulation. So first one, it tried 12 stocks. This is our best combination for those 12 stocks. Now it's a size of 10. This is our best combination for those 10 stocks. Now it's a size of, next one is a size of 8. This is the best combination for those 8 particular stocks. 6 stocks. I'm looking for the higher return number here, just so you guys know. 6944 1.09. Okay. So we're getting a return of 1.09 for our smallest portfolio yet, which are these 4. So now here's kind of where we come back to our previous discussion, right? How many of you would have thought to put these 4 stocks together? It's according to this is our highest return yet, right? Who would have thought to put these 4 stocks together? And by the way, I don't know who Mara is, M-A-R-A. I don't know who that is, but MSTR is MicroStrategy, AAPL is Apple, and then obviously this is Tesla. I don't know who this one is, but give me an unbiased rationale for how you would have put these 4 stocks together. I'll wait. Tej says, Dennis, are you sure that historical data period is not a valid hyperparameter? Shorter periods are more responsive to recent trends, while longer periods capture broad patterns. But we already have 2 years, right? We're using 2 years of data. So I think we're okay from being exposed to shorter trends, right? But I assure you that data itself is not a hyperparameter. It can help or hurt you, but it's definitely not a hyperparameter. Leo, which portion are you referring to here? Sorry, I was doing code, not chat for a while there, so I don't know which one you were referring to. Let me know, please. But again, the question in front of the chat right now is who would have put together MSTR, Apple, Mara, M-A-R-A, and Tesla? Give me some rationale for how one of you would have come up with that combination of 4. Still waiting. While you think about that one, right? Because I want to know how you combine MicroStrategy with MARA. Let's look at some of these other results. So here's the one with 11. Who would have put NVIDIA and oil in the same portfolio? Give me your rationale for why you would have chosen those 2. I'll wait. There's Mara again. Mara, Amazon Gold, and Snow. I don't know who Snow is. Who is Snow? But feel free to tell me how you would have come up with these, right? If anybody wants to volunteer, let me know. Well, Leo, it's not if you agree with the combination, it's would you have come up with it on your own? Right? Because that's the win, right? The win from data science is, whoa, wait a minute, I would have never thought about that combination. So yes, it makes sense in retrospect now when you look at it, right? But again, this is why we do the randomness. That's how you're going to find those insights, right? So don't think of it retrospectively. I want to know how prior to running these, prior to seeing these four, you would have said, oh yeah, this because they're in the same sector or because they have great PE ratios or right? Mara is a digital holding. Okay, thanks, Leo. But yeah, I mean, look at these, right? Yeah, I mean, if you guys can come up with reasons why, I wouldn't. That's a fact. Yeah, so that's the win, Leo, right? That's the insight. The insight is that these four stocks can do well. When you look at them later, it's like, oh, great, I get it. But you don't know that going into it, right? The algorithm told you that, not the other way around. Yassine says, but would that mean there's no possibility we could have done better with choosing some with our bias? I think we can at the end of the experiments test some of our bias combination. I think that can do no harm. It's not harmful, Yassine, but it's also not data science. Right? It's not data science because one, we ultimately don't care. We're distanced as scientists from that. And two, we're not a business team. We're a technical team, right? Our responsibility is to produce the best code and the best model possible. So I'm using these examples when I ask you about would you come up with this combination as a little bit of a reverse on that, right? Because if you couldn't come up with that combination, then why would you think that your own biased view would do better? Like one of those doesn't support the other, right? So, and also, I mean, keep in mind that it's also one of those things. It's an error of omission, right? I mean, look at this, right? Look at this. This portfolio is telling us that 22% should be in T. For those of you who don't know, T is AT&T, which is one of the phone companies here in the US. Very old company. A lot of people don't invest in it because, it hasn't been doing so great. It's kind of viewed as an old technology company, right? Because they've been around forever. But 22% of our holdings should be in T according to this, right? If you didn't include that because, oh, that's an old company, yeah. But look, it says I should invest in Netflix or whatever, right? Now you're doing the error of omission where you could get an okay portfolio, but not the best portfolio, right? Leo says, I understand your point. We're not here to define which one is best by looking in depth. We're here to raise what are the best ones, say why, and leave with the business team. Yeah, we're here to raise the code that selects the best ones. Yeah. Just to be a little bit more accurate there, Leo. Our responsibility is the code. Right? So look, here's what I really want you guys to think about, right? Because we have a massive weakness in our approach here. Massive weakness. And these are the types of things I'd rather have you guys focus on. Because I don't care about Netflix or Nvidia or my personal investment biases. I care about the data science of it, right? So think about this. We told the portfolio, we told the code to run between 3 and 12 stocks, and we gave it 50 stocks to choose from to fill in, right? And then we also told it to run 50 simulations. One of those numbers doesn't go with the other. Can anybody find it? Because that's what I want you guys to think about. That's where you're applying data science. 3 to 12 stocks, 50 total stocks to choose from, run a simulation 50 times. One of those numbers does not belong. Which one is it? Leo says, yeah, using DS tools. Yeah, exactly, Leo. So that's the question in front of the chat. The parameters we gave are 3 to 12 stocks, 50 stocks to choose from, run 50 simulations. There's a massive problem there. What is it? Yeah, that's right. Yeah, Yassine got it right away. Not all possible combinations. And we don't have to run every single possible combination, but 50? 50 is like a tiny, tiny, tiny slice of all the possible results, right? It is a woefully small number of results. So see, Yassine, now you're applying data science, right? So forget about the stocks you like, forget about the money, forget about anything. Now you're applying data science when you're thinking about the permutations, the number of instances, what your reports look like, the way you're formatting the reports for ease of use. See, now you're doing data science, right? 50 stocks represents a sampling bias. Yeah, sure. I did choose 50 just to kind of, keep the permutations reasonable, right? But yeah, in theory, we should be testing every single stock, right? Yeah. So in that case, I actually stand corrected. There's two massive problems in this simulation, right? Maybe we should be asking for the, if you remember when we went back to do the data pipeline, we asked for the top 50 stocks. Maybe we should be asking for the top 2,000 stocks or whatever, right? So yeah. And then we need to run more permutations, right? That would increase the number of overall cycles we need to run too, right? But see, guys, now I'm encouraged again. Now we're friends again. See, before we weren't friends, but now we're friends because now we're still talking data science. Now we're not talking about our biased opinions. Now we're taking a look and saying, have I done enough of a search, enough code, enough permutations, enough tests, right? Because we are scientists in our lab. Have I conducted enough tests to cover as many possibilities as I can? Do I still have time? Do I still have CPU resources? Do I still have an appropriate data set to work on? Is my pipeline still good? My data pipeline still good? See, now we're talking about data science stuff, right? Lakshmi says, so with randomness, lots of permutations and combinations are happening and it's coming up with the best possible combination. Am I getting it right? Yeah. Now you're thinking along the right track. You're not going to get every single permutation right because you'd have to write special code to do that. But the more permutations you write, the more coverage you're providing over your potential population, right? If you think of all the permutations as your population, the number of simulations you run lets you cover more of that population. So yeah, Lakshmi, you're on the right track there. Leo said, we weren't friends there for a while, guys, because I'm not an investment advisor. I don't care about these, right? We are a data science team. You got to think about it from the data science perspective. See, because now we're having more of these data science conversations, right? Because you're on the right track, right? 50 is nowhere near enough number of samples. Tej is now on the right track, right? Because Tej is saying, hey, we're only looking at 50 stocks, right? So now we're really working, right? So yeah, so I hope that this is the start. And also Lakshmi, now seems to be on the right track too. I hope this is kind of making those little adjustments in your mind, because that's kind of what we need, right? We need to start thinking about it as data scientists, not investment advisors, not business people, things along those lines, right? There are limited inputs that we should have on the business side, but Let's focus more on the data science side. Lakshmi says thanks. Khalid says we are friends. Well, we're friends now. 20 minutes ago, I think some of you were going crazy. 20 minutes ago, I was ready to start using the ban button or something. Because, I mean, I get it, right? Stock data, we all think we know about stocks and all that. Everybody's excited about investments they want to make or they may have or whatnot. I get it. I tell you guys, I like investing in gold. That's my thing. But we're only friends if we're talking about data science, guys. Okay. But I think now we're on the right track, right? Now we're thinking like data scientists. Hey, are we covering enough permutations? Is our pipeline big enough? We had a pipeline of 5, which was like this, and then we went to 50. But maybe our pipeline needs to be like this. Right? So now we're talking about things that are within our team, our data science team's control, right? So good job, guys. Good job. Leo's also laughing again. Yeah, Leo, we got to stay focused on the data science side, right? I know that the stocks can always be like a everybody thinks they're good at picking stocks, right? Nobody thinks they suck at picking stocks, right? But that's bias. That's bias, right? So, you got to be careful with that. All right. So, Lakshmi's also laughing. Yeah, it's been an interesting session, Lakshmi. All right. So, I'm trying to decide where we go from here. Where are we going to take this from here? So let's go ahead and ask it to do the same items, but in a single report. This is messy, right? Because we talked about how we're scientists, we need to be organized, we need to create a report for ourselves. This is not an effective report. It's good that we're getting these numbers, obviously. But is the report effective? Probably not, right? This is not an effective report. So let's go ahead and fix that. And actually, let me quickly look at that. Anfas, welcome. Anfas, I think you might have joined us previously under a different name. Did you update your name? But Anfas, good to see you. Feel free to follow along. We're doing our Sunday tutorial. So we are 2 hours into this. So we'll see how much longer we're going to go. But welcome. Good to see you here. All right. So let's go here. All right. I think this should get us there. And then I want to specify that I wanted to produce the entire file. Because I'm really not comfortable when it just gives us the little snippets of changes. I'd rather see the entire thing. Leo says, are you happy with the results even when we're not running all the permutations? I'm not sure I care, Leo, right? We're not a business team. I don't have to be happy with the results. Only the client does, right? So I'm not sure it really matters to me. I'm suspicious of a couple of the values. Some of the return values do seem a little low. So that might warrant a little bit of investigation. Kind of like line by line on the code. But otherwise, we as data scientists should be a little bit divorced from the results, right? All right, and so it's going to put it in all simulation results.csv. So that sounds good. Let's go ahead and run this. Oh, I got to save it. So unfortunately, we're not going to get updates as it goes. It's going to write it at the very end, but that's okay. There's worse things in the world. Let me go back to the chat, see if there's anything else. By happy, I meant okay with the method utilized. Sure. I mean, I think it was Manoj that had originally suggested Efficient Frontier. Again, this is me being a data scientist, not an investment advisor. But I mean, I'm happy with how fast each of the simulations are running, right? This is all on local CPU, and we're doing 50 simulations of 20,000 Monte Carlos in a very reasonable amount of time. So from that perspective, sure, I'm happy that the model is running and we're able to get to reasonable answers. I think ChatGPT is doing pretty good with the code. So yeah, in that scenario, sure, I'm happy. But again, I mean, that's me being divorced from the actual problem. Guys, this comes back to something else that I've shared in my previous content. And I also share this with my clients when they're building out their teams, right? A good data scientist can work with data that's unlabeled, right? Like you should be, if you're telling me you're a good data scientist, I should be able to give you data that doesn't have column names. It'll just have numbers, and 10 columns, 12 columns, whatever. And you should be able to tell me something about that data set. And that data could be wheat prices, or it could be, Russian missiles. Like you literally do not care, right? So that's kind of like what there's a little bit of that element in our stuff today, right? Our care is that we are writing the best code with the best methodology possible. And then here, business team, here's the results. We don't care what they think, what the results are. We just care that we followed a good methodology and that we covered as many possibilities. We ran as many tests as we could. That's our responsibility, right? So in that situation, yeah, I am happy. I think we're on the right track. I think we've spotted our own faults, right? We've already identified 2 things we could be fixing to help ourselves out, right? So yeah, by those measures, I think this is it's progressing nicely. All right, so let's look at this new file. So here it is, all simulation results. And there we go. So the first column is an ID of sorts. And then the next one is the portfolio size. And then the returns and the Sharpe ratio. Okay, so these returns make more sense. Why were we not getting those numbers before? That's crazy. Oh, wait a minute, why? Ooh. Oh. Oh, that's terrible. Oh, that is terrible. Why did you do that, ChatGPT? Why did you do that? So, do you guys see what's happening there? ChatGPT is using each ticker symbol as a column, and then telling us the proportion of each of these stocks to choose. So that's why there's so many blanks, because in this scenario, only so many of those 50 are chosen. So the rest are 0 by default. This is a terrible output file. I can't believe it did that. So we kind of need to make an adjustment there. But Leo, you know, what's interesting here is I just told you guys that I was suspicious of the return values, but here the return values make a lot more sense. Because you can see here the return value is the third column, and now you're getting, you know, numbers that kind of are more in line with what the stock market has done the past couple of years, right? So yeah, let's adjust this output file by ChatGPT. Let's see. So let's define the columns we're going to need. All right. So we're going to ask it to have the last column be the portfolio column and only include the ticker symbol, the weight, and only include ticker symbols that were actually part of the simulation. Oh. Okay, this is this it? Nope, still generating. Okay. So in this scenario, we are going to make our own change. We are going to put our thumb on the scale here, because since we're testing the output, we don't need to run all 50 simulations, right? Let's just run 5 simulations, make sure that we're getting the right output, and then we'll let it fly for the 50. Okay, cool. So if we go back to Visual Studio, here's all simulations. Okay, cool. So now it's going to show us the portfolio and the proportions. Oh, this looks great. Okay, so this one is only 1, 2, 3. Is that what it was? Okay, cool. Yeah. Okay, so look at this line, guys. So here it's simulation number 2, 3 stocks, 32.9% return, Sharpe ratio of 1.8, and it should have, and that combination should have been Amazon, Grab, and IBM. So those 3 stocks, with IBM being 53% of your holdings, and then Amazon being 33%, that would have netted you a 32.9, 33% return. How many of you would have picked IBM? IBM couldn't be any less of a sexy stock right now, right? Everybody wants NVIDIA, nobody wants IBM, right? And that's okay, but that's a bias, right? But this is the insight. This is the insight that we're gaining by using this unbiased approach, right? So this output looks a lot better. So now I think we're ready to run it for 50 instances again. All right, so let's do 50, do that, and then, yeah, and then we go back to the terminal. All right, so we'll let that run. But I think we are getting to a near complete state here, guys. Near complete. All right, so it's been saved. It's in my Visual Studio. If I go here, yep, that looks pretty good. The dictionary looks great. And by the way, I saved it as a dictionary object so that we can come back and refer to it later, right? We can programmatically pick up the best result, right? So I want to go ahead and do that. Give me just a second here, guys. So here, this will be a little bit of a better format for all of us to take a look. You can see the Sharpe ratio, you can see the return, and actually let me make that a little bigger for you guys. How's that? I think that's a little better. I think it's a little bit more readable. And right now you can see it's sorted by the portfolio size. But what if we sort by the return? There we go. So our maximum would have been with 5 stocks, 162% return, Sharpe ratio, and then this is the portfolio. BBD, SOUN, APP, IONQ, and GRAB. Tell me which one of you would have come up with that combination on your own. Like, you can't, right? That is the test. That is the win, right? Or the experiment, I should say, right? Or this one would have been Tesla, BBD, and CLSK. Does anybody know what stocks those are? Somebody look those up, please. CLSK, I think that's a pharmaceutical? What is CLSK? I don't know that. Tesla, obvious. BBD? What is that? Somebody look those up, please. But that's your best 3-stock combination, right? And then we can chop up the data, right? Because now we could be like segmenting and say this is the best 3, this is the best 4, this is the best 5, right? And we don't care what they are. We're just presenting this to the client, right? Okay, so Tej says, is the return a predicted return for the next year? No, Tej. This is all backwards looking, right? So at that point, we kind of go back to the model selection. Or not the model selection, but the explorations we did. Where we talked about time series, we talked about sentiment, we talked about efficient frontier, right? So no, this is backwards looking based on historical performance, right? So that's where It's more of a fundamental question of, well, should we have explored this anyways? That's not really a data science question per se. But it could be something where the client specified it, right? The client could have specified, we want you to do this with data science, and it has to be the efficient frontier theory. Like that's possible, right? That they would specify what it is. Or, for example, we chose, in pretend land, we said that they want the maximum return. Not every client wants maximum returns. A lot of clients want the minimum volatility, right? So maybe, you'll have to be guided by that. That's your best result, right? And there's a lot of reasons for that, mostly business reasons, right? But no, Tej, this is backwards looking. So there is something to be said for that. Time series forecasting, that's forward looking, right? That's using the historical data, applying its own proprietary methods, and then creating a forecast, right? So that one you could argue is forward looking, even though it's using backwards facing data. Okay, BBD is a Brazilian bank. That's in the top 50? That's crazy. Okay, I didn't know that. CLSK is a Bitcoin miner. Okay, cool. Thank you. Okay, so who wants to raise their hand and tell me that they would have come up with a Tesla, a Brazilian bank, and a Bitcoin miner as the top combination for 3 stocks in a portfolio? Like, nobody would have come up with that, right? I think that's what Michael meant to say, right? Michael's meant to say no one, right? Like this is why we do these experiments, right? So if we had taken the time to go out and do the PE ratios, well, guess what? You would have probably lost Tesla, right? Tesla has a terrible PE ratio, right? Or maybe somebody would have said, BBD, a Brazilian bank, that sounds risky. I don't want to include that, right? Or, maybe some of us in the chat are, don't believe in Bitcoin. And it's like, ooh, a Bitcoin miner? Ooh, is that still a thing? Ooh, yeah, let's not include Bitcoin. But you don't know, right? You don't know. That's why you do the experiments. That's why you do them randomly. That's the only way to, remove as much bias as possible, right? So we have a pretty good report, and we have a way for us to chop up this data. And this is kind of another place for a client conversation to say, do you want us to just give you the one result, the portfolio size and what the portfolio is? Or do you want to see the top one for the 5 stocks, 6 stocks, 7 stocks, so on and so forth, right? So this is where, we as a data science team have done our job. We're pretty good on the methodology. We like the code, and we have an organized report, right? We had a creative discussion on what we're going to test, like the hyperparameters. So we basically have met all 4 of the different items. If we go back to our goals here of the champion model process, right? We did our creativity. We identified our hyperparameters. We have the code. We see it running in a reasonable amount of time in our 50 cycles and all that. We're trying to keep organized records, right? Initially, we got terrible results with a report for each test. The first consolidated report looked terrible. So now the third iteration of our reporting is looking pretty good. We know the hyperparameters that were used for the model, right? That's why we asked the number of stocks and the stocks that were used. And we have a baseline, right? We decided to talk to the client. The client said the baseline is total returns. We don't care about volatility. Just give us the max return. And now we have a baseline. Our baseline right now is 162%. 162% is the return, right? So now, as we run this more, because we agreed that 50 simulations is probably not enough, as we run this more, we're going to get more results. But we already know how to get to 162. So now we're trying to beat that, right? So let's try it. Let's go through one of those iterations. All right, so everybody remember that for 5 stocks, no, excuse me, for everybody remember that the number to beat right now is 162.3%. All right, and we're gonna start a much bigger run. Actually, I'm gonna cancel that. And now we're gonna start a much bigger run. I want to go ahead and save this. I want to kind of keep this in time. We're gonna rename that. And then we're gonna run this for 500 instances. So we're 10xing our efforts now, right? We're going from 50 to 500. And keep in mind, in a real world scenario, we'd want to go a lot more than that. I'm just using 500 as a, you know, just to keep it compact for the stream, right? Just to keep things moving for the stream. All right, so we can just run the same thing over again. And now it'll create a new all simulation results file. And we can look at it again, just as we did the other one in the spreadsheet format. Okay, so Tej says, isn't the business problem concerned with what is going to happen in the future? But I get that we are looking for the point of view for a tech team. Yeah, sure. But again, maybe the client was the one that suggested the model, right? Maybe they read about the model, they just don't know how to implement it, so they came to us. That's a very common thing in business, right? Because the reverse holds true, right? They're a business team, not a tech team. So even if they read about a great model, doesn't mean they know how to write it. That's why they would bring us in, right? So yes, it's backwards looking and may or may not be valid in the future, but we don't care, right? We're trying to fulfill the whatever the client request was, right? So keep that in mind. All right, so that's only gonna fill up at the end. There's nothing to monitor during it, but we know what this looks like. Let's see what the new one looks like. All right, guys, so I think we're gonna take a look at these results, right? We're trying to beat 163, right? I'm just doing this to kind of give you guys a flavor for the process, right? Like, you would repeat this over and over again. You would choose to run, I don't know, 50,000 simulations, and you would leave it on a Friday night over the weekend, and then you come back Monday morning to a report, and then what are you doing? Then you are going back to our methodology. You are interpreting results, right? You're down here. What did the results say? Have you beat your baseline? Great. What does that look like? No, we didn't beat the baseline. Oh, okay. That means that your other model is still holds, that model is still the champion. What else can you be changing, right? And then so on and so on. And these are the cycles, right? This is what the arrow represents, right? You just repeat those cycles over and over again until you reach a desired result or you run out of time, right? So any other questions? Because I think we're going to wrap up shortly after this finishes here. We are approaching 2.5 hours, which is amazing. Thank you to all of you for sticking in there with me. But yeah, I mean, this is the work, guys. This is us working in the lab. This is our lab. This is our lab, and data are our tools, right? That we used to run the experiments. Any other questions, guys? I'm so happy we can finish up this this session with all of us as friends, because you know what? You guys were hurting my feelings there for a bit. I was, you know, I was ready to curl up in a ball and cry after this session for a while there, but I'm feeling pretty good about it now. AJ, I'm gonna come back to it, okay? All right, so we are running almost halfway through our 10x of the simulations, right? So let's have a little poll. Give me a 1 or a 0 in the chat. Give me a 1 if you think we're gonna beat our current baseline. Give me a 0 if you don't think we're going to beat it. What do you guys think? A 1 if you think we're going to beat the baseline. A 0 if you don't think we're going to beat the baseline. What do you guys think? Let me know. Drama King is back. I'm not drama. I'm just saying, guys. I'm just saying people's feelings were going to be hurt at the end of this stream if we didn't end up as friends. But, you know, now we're friends again, right? But for a while there, you guys were not my friends. Okay, Tej says 0. Tej says you don't think we're going to beat it. Okay, okay. Anybody else? A 1 if you think we are going to beat the baseline. A 0 if you don't think we're going to beat the baseline. And Tej, when people are finished voting, I want to hear your rationale. Leo says that's tricky. Ooh, I don't know, guys. I don't know. Let's start with the votes, but then I want to hear your rationale. And then I'll give you guys my vote and my rationale. All right, so there's a 1. Leo is a non-voter. Tej is a 0. Anybody else? Give me a 1 if you think we're going to beat the baseline. Give me a 0 if you don't think we're going to beat the baseline. Okay, so we got another 1. So the 1s are leading. A 1 if you think we're going to beat the baseline. A 0 if you don't think we're going to beat the baseline. Michael, my good friend from Nigeria, thanks for voting. Anybody else? Last call for votes? So Leo and Tej, start putting in your rationale. I want, well, maybe, well, yeah, both of you, because both of you are kind of like 0 or leaning towards 0. I want to know your rationale. But anybody else who wants to vote? A 1 if you think we're going to beat the baseline, a 0 if we're not. Last call for votes, guys. Okay, Lakshmi is also voting a 1. So Tej, Leo, let me know if you want to include your rationale. Almost at 500. So Tej, would really love to hear your rationale because you're in the minority here, and that's okay, right? I always encourage you guys to take an opposing view, right? Nothing wrong with an opposing view, but would love to hear your rationale. Okay, Manoj is also team 1. Nah, Leo. We can't wait. You gotta have a stance. I mean, look. So maybe Tej doesn't want to provide rationale, and that's okay. Look, clearly the smart money is on voting 1, right? The anything is possible, of course, right? But on a probability basis, haven't we really expanded our search now? Like, aren't we trying so many more combinations now? Like, yeah, right? We were trying this amount of combinations. Now we're trying this amount of combinations. So the smart money is on saying that, yeah, we have increased our probabilities of finding a better model, right? That probability has gone up significantly, right? So the smart money is definitely on voting 1. Now, you could vote 0 if you say, well, dang, 163 is a pretty high number. 163% return. I'd love to get that much return. That's a lot of money. Oh my gosh, Tej, you wrote that as just as I said it. Oh, Tej, we're not friends anymore, dude. You can't do that. See, you're letting the bias affect your view. Well, you're letting the bias affect your view as a data scientist, right? Because I agree with you that it's possible that we won't beat that. But again, we're divorced from that. From a data scientist perspective, we have greatly increased our coverage on that search. So the probability has gone way up that we can find something better, right? So yeah, Tej, don't let those numbers throw you off like that. Because you'll never know what you missed out on, right? So yeah, if anything, the smart bet is to say that you're going to beat it, because now we're 10xing the combinations, right? So let's look. We haven't looked yet, but again, from a data scientist perspective, you're covering so much more. But definitely do not let the number itself or the money or anything like that affect you. Right? Yeah, Leo, that's kind of weird that I said it exactly as he typed it. Yeah, that was weird. But let's look. So let me bring that up again, guys. Oh no, what? Oh. All right, guys, so here it is. This is our latest, I believe. Let me verify that. There should be 500 rows. It looks like it is. Cool. All right, so return. Descending. 165. So we did beat it, guys. We beat it with a 4-stock portfolio. IONQ, BBD, APP, and INTU. I don't know IONQ. If you guys want to look these up. Oh wait, let me make that bigger, right? Is that better? Yeah. IONQ, BBD, APP, and INTU. If you guys want to look that up. Leo says, but if the majority of those combinations involve poor stocks or out of our criteria. But that criteria may not be our criteria, Leo. It might be what the client told us, right? We don't know what they want, right? We're just, to some degree, we're just the hands at the keyboard, right? Again, we're kind of divorced from the results. Like in this scenario, we went out and got the data ourselves. In some cases, maybe the client provides the data. And if the client provides the data, then what can you say? They gave us the data, right? Like this is just a reflection of those results, right? But yeah, if you guys want to look these up, what's interesting too is that right below it, there's another one that's 163.9, which is technically higher than our previous baseline. So we actually beat it twice. And this one is a completely different combination. This is CLSK, MSTR, F, and AMD. So that's AMD, that's Ford, that's MicroStrategy, and then the Bitcoin miner, right? So you could argue that 3 of those are correlated to Bitcoin, right? Because MicroStrategy is basically a Bitcoin stock, with those psychopaths that are running that company. But again, you don't know these combinations unless you're trying them, right? Like you would have never come up with these. But we did beat the baseline. And like I said, that's where the smart money is, right? Because you're adding so much more coverage to your testing. But definitely don't let that sway you as far as like, well, how can we possibly beat 165? That's a lot of money. Well, but who cares? We're a science team, not a business team, right? All right, guys. So I think that's a pretty good segue. Let me quickly address AJ's question. AJ, so remind me, what is the shipping company optimization problem? I can't remember what it was. AJ, give me the cliff notes on that. What's the summary on that? The shipping company optimization problem. I'm sorry, maybe I'm just getting old, but I can't remember that we ever talked about that. And you said it was last Sunday that we talked about that? If anybody else remembers, please let me know. Give me the elevator notes. But I think we've had a good discussion today, guys. And I just want to keep on stressing it to you guys, right? Don't let your own biases guide your tests. You would never know unless you run the tests. That's why you do them, right? And you got to design those tests as unbiased as possible. Okay? The job offer that you received. The shipping company? How would you win what problem? AJ, give me more than that. A job offer from a shipping company? You see, AJ, sometimes I make up the companies, right? Like I'll change the type of the company, as like an obfuscation type of strategy, because I don't want to like blow anyone up or anything, right? So give me a reminder. What else did I say about that? I've never received an offer from a shipping company. Unless you mean like the hospitality company, the one like the cruise ships, or like what are you talking about? Is that what you mean by shipping? Because when shipping, I'm thinking like boxes. But let me know, AJ. You got to give me a little bit more info. But again, sticking with our current problem. I hope you guys are getting a flavor for that process. The iterations you're going to have to go through, the discussions you're going to have, the awareness of the bias that you're going to have, okay? Okay, so AJ says the cruise companies. Okay, yeah, so for those of you that don't remember, I can't believe that was a week ago. I feel like I just told that yesterday. I once received an offer from a hospitality company. They're a cruise ship company. I'm not going to say anything more than that. Don't want to blow anybody up. Big company, 40-something ships across the world, in different cruising regions. And they told me that they spend $1 billion a year on gas. And my job was to come in and help them reduce that number. So I'm pretty sure I already gave some insight into how I would do it. But the first thing you got to recognize is that there's two sides to that problem. There's the usage, and then there's the procurement, right? Can we use it better, or can we procure the gas better? Both of those are a win, right? So on the procurement side, it would be very much like, it would be very similar to the stuff we're looking at now, because a large company like them, they don't just buy gas. They probably buy on the futures market, right? There's probably a futures market for shipping gas. I don't know this to be a fact, but I'm pretty sure that's the case. So how do you optimize your purchases on the futures market vis-a-vis where you think the market is going and what those premiums are like, right? So that's more like an options trading exercise, right? And there's a lot of data science you can apply to that. I don't want to get into that too much because, again, I'm not a financial advisor, and, that's almost like another type of math to talk about. But that's the first way that you would approach it. I don't care about the ships. Have as many ships as you can. I'm just going to buy your gas in a better way, right? Because that still meets the goal of lowering the amount, the $1 billion that they invest in it, right? On the shipping side, there's a lot of things you can do. You can talk about optimizing the routes that they're taking. You can talk about optimizing the ships themselves. There's a lot of technology that goes into those ships. There's a lot happening below the ships. They have like these hydrofoil type of engine or type of wings throughout the ship, right? So I did some preliminary research about how some of those designs can have an effect on speed and time, which is ultimately reflected on gas, right? And then on top of that, you can apply some domain knowledge to when that gas is or not when the gas, but when the ships are used. So for example, just because you spent money on gas for the ship doesn't mean the ship is being used, because you have to account for like ship maintenance or the relocation of ships, right? If you're moving from one ocean to another, that's an empty cruise. Those happen, right? There's these empty cruises that happen. So you have to apply some domain knowledge to say, well, can I optimize the gas usage at each one of those, right? The routes, the design of the ship, and when the ships are being used or not used, right? Because not every mile is a revenue generating mile, right? So off the top of my head, I mean, this was years ago, right? That's how I would have approached a problem like that, right? But really the key takeaway for all of you guys, and I've said this before, there is always more than one way to use data science in any business and in any problem, right? So again, you're thinking a cruise ship company, you're thinking, great, I'm going to optimize their sales. Well, that's only like 10% of what the company does, or 10% of what you could do for that company, right? So that's how I think about it, right? So even though they define the problem for me, there's still like sub branches that you can find. So I know I'm speaking fast, but I'm just giving you a brain dump because these are the things that just come to me, right? But I mean, this is me like years and years in the business, right? But that's how I would have done it. Where can I buy your gas better or can I use your gas better? Either way, it's a win, right? And if I can do that just 1%, 1% of a billion is a lot of money. So, it's small wins that are possible there. AJ says, is it a reinforcement kind of problem to solve? That's not the right question, AJ. That's not the right question, because reinforcement learning is a tool, not a solution, right? The solution comes from the creativity and a little bit of the business side. And then can that end up as a reinforcement learning problem? Sure, but I don't care if it does or doesn't. I'm not looking for it to be a reinforcement problem, right? So yeah, I mean, yes, it could be, but it could be a neural network. It could be something else. It could be XGBoost. It could be regression. Like, who cares? That's not really the question to ask at that point, right? The question is just how can I better define the problem, and how can I think about it from a scientific method perspective, right? So that's the better question. Because if you think about what I just said, right? That means I'm forming a hypothesis. My hypothesis is that I can apply machine learning to the petroleum futures market for better purchases for a hospitality company, right? The hypothesis is not this is a reinforcement learning problem, right? Like that's two completely different takes. So you got to think about what is it that you're trying to solve, not what tool can I use, right? All right, guys. So happy to answer that question, but I really want to stay focused on our Sunday series because I know a lot of you just attend for Sundays. So thank you so much for today. I'm really glad we talked through a lot of things. So again, closing note, always think of the meta view, right? We are data scientists that are divorced from the business, divorced from the results, divorced from money and company biases and all that. Our job is to produce the best code that we can in the most organized way to give the clients potential results and say, hey, this is what our findings are. We're not telling you what to do, but these are what this is what you tasked us with. Here's what our experiments resulted in. So to Denelson's previous question, that final delivery is going to be with an article with saying, hey, this is what our results mean to your business, right? So let's think about it that way. Let's think about how data science is the removal of bias, right? So be careful, be aware of your biases, and we'll see where we end up next time. Real quick, guys. So I'm taking a stream break. Next week is a holiday week in the US. So I'm going to, be spending time with family, but I will be back next Sunday for the Sunday session. Okay. So there will be no break in the continuity of the Sunday session, but I won't be streaming during the week because of the holiday. All right. So thanks a lot, everybody. As always, craziness out there. So please take care of yourselves, take care of your families, and I'll see you next time.